In this video, we're going to solve 2006 AP Calculus ABFRQ question number 1, Form A. So it says, let R be the shaded region bounded by the graph of y equals n of x and the line y equals x minus 2 as shown above. Find the area of R. So we need to find the points of intersection. So we need to find these points. So now, using your TI-89, or whatever calculator you have, you would hit solve. Now you would do top minus bottom, so ln of x minus quantity x minus 2 equals 0, comma x. So when you solve this, you're going to get a equals, or about it equals 0.159, and little b would equal about 3.146. So now if you want to find the area, you would do a equals, from a to b, ln of x minus x minus 2 dx. And remember, a is the 0.159 and b is 3.146. And when you use your calculator to solve this, you should get about 1.949. Okay, part B says, find the volume of the solid generated when R is rotated about the horizontal line y equals -3. So now, you basically have this. This is what it looks like. If you rotate it around -3, it looks something like this, and then -3 would be in between. So let's use a different color. So it would be around a line that looks something like this, and this is not drawn to scale by any means. So now, drawing this, and I'm not the best drawer, this is your outer, so it would be outer squared minus inner squared. It would be this right here. This area here times all the thickness, all of them done together. So now drawing it over here, it would look something like this. Be a bunch of washers bunched up together. So now when we start this, it would be V equals pi, same boundaries, A to B. And now when you do this, we need to find our outer radius. So what would our outer radius be? Our outer radius would be this white piece right here, from here to here. From here to here. So when you do this, it's going to be ln of x plus that -3. And it would be squared, that's outer squared, plus -3, not minus. Well, it would be minus -3, but which would make it plus. Okay, minus inner squared. So now when you do inner squared, it's whatever that line is. This line over here, from here to here. So now, luckily that's an easy function. It's x minus 2 plus 3 quantity squared dx. So now when you solve this, you should get about 34.199. Also, if you really wanted to, you can make that into +1 and then just keep it in the parentheses. Okay, part C, write but do not evaluate an integral expression that can be used to find the volume of the solid generated when R is rotated about the y-axis. Okay, so what we have over here is if we rotate it about the y-axis, it would look something like this. And I can't draw, so please forgive me. So drawing the next part would look something, actually that should be the straight line, and then it would look like this. And times all the thicknesses in between. But now if you look at this, this is actually in terms of y. So each thickness is dy. So when you do this, it's going to be pi. Now we have to find our y values. Luckily, we have this function, y equals x minus 2. So what you could do is you could just do a minus 2. And you could do b minus 2, because if you plug them in, it gives you your y value. And I'll rewrite it in a second. And now we have to convert all our values into terms of x equals, so, well, in terms of y. So it's y plus 2 equals x. That is going to be the line on the right. Remember, it's right minus left. And then the other one was ln of x equals y. So it'd be e to the y equals x. So now the right function is going to be the y plus 2. That's the outer squared minus the inner squared, which would be e to the y quantity squared dy. And if you really wanted to, what you could do is you could write it in terms of the numbers. I actually plugged them in and did it. And I got the first value to be negative 1.841. And the other value was 1.146. And this is, of course, what the volume equals. Volume equals, I needed to note that. And it would be the same function above. Okay, I hope this video helped